Good afternoon. Thank you so much for being with us in the second session of the virtual presentation in IHSATEC 2023. Okay, right now, we some of the presenters and also the session chair. Okay, we have Dr. Mossad. Okay, good afternoon, Dr. Mossad. Okay, let me check Dr. Karan because previously she was here. Okay. Okay, Dr. Mossad, do you hear my voice? Which one? This one?
He leave.
Which one? Not yet, not here. Oh, here. Okay. Yeah. Okay. Okay, please to give me feedback. Are my sound is clear? Okay, thank you, Miss Siti, for the feedback. Okay, let me check. Dr. Mossad already here? Dr. Karan, are you here?
I'm here.
Okay, good. Thank you so much. Okay, Dr. Mossad, Assalamualaikum. Still muted, Prof. Still muted, Prof. We cannot hear your voice. We cannot hear. Okay, good.
Assalamualaikum.
Okay, good. Okay, Assalamualaikum, Prof. Thank you so much for being with us right now. Thank you for your time, your energy. Thank you, Dr. Karan, for your time also. So I will open first the session. Then after that, I will move to the session chair, you and also Dr. Karan, to leading the session, ya, Prof, ya. Okay, let me to share the slide. Okay, so I will open the session. So welcome to the IHSATEC 2023 with the online academic presentation, Science, Technology, and Innovation in the second session. The session will be held at 1 until 3 p.m. at Bangkok time. So please to be prepared to all the presenter and also the attendees and the co-author of the presentation. Okay, so we have some of the session chair right now. Thank you so much, Professor Dr. Mossad Athiya Abdel Wahab, from Professor of Toxicology and Pharmacology, Food Toxicology and Contaminants Department, Food Industries and Nutrition Division, National Research Center, Egypt. And also we have Dr. Karan Wang Paibon, from Department of Biochemistry, Faculty of Science, Chulalongkorn University, Thailand. Thank you so much again, Prof. Mossad and also Dr. Karan for your time. Yes, okay. So before I will move forward the session to Professor Mossad and also Dr. Karan, please allow me to read the profile of the Professor Dr. Mossad Athiya Abdel Wahab. Professor of Toxicology and Pharmacology, Food Toxicology and Contaminants Department, Food Industries and Nutrition Division, National Research Center, Egypt. Dr. Mosad Atia Abdul Wahab is a professor at Department on Food Toxicology and Contaminant, National Research Center, Egypt. He got his PhD in toxicology from Texas A&M University, Texas, USA. He is the president of Egyptian Society of Science and Halal Product and a member of several professional organizations. He acted as the visiting professor in several universities at several countries. He conducted more than 25 research projects in the area of food safety, food contaminant, nanotechnology, and natural product funded by national and international agencies, and got 6 patents. He published more than 220 research articles in the international journals and several book chapters. He supervised more than 35 MSc and also PhD thesis and participated until now in 45 international conferences as invited or keynote speaker. He is the co-editor for 220 international journals and was honored and awarded several prizes from many international and national agencies. Okay, next, Dr. Karan Wang Paibun from Department of Biochemistry, Faculty of Science, Chulalongkorn University, Thailand. Area of expertise of Dr. Karan are carbohydrate active enzymes, biological activities and application of oligosaccharides and polysaccharides, bacterial biofilm starch metabolism in plant, and the qualification and education of Dr. Karan, PhD in biochemistry and molecular biology, Chulalongkorn University, Thailand, BSc Biochemistry, Chulalongkorn University, Thailand. Okay, now again, thank you so much and welcome to this session. So I will move forward to Professor Musad and also Dr. Karan to lead the session. Please welcome.
Okay, thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh. I would like to express my great thanks to be with you there and now. And I am sorry that I cannot participate myself in this conference because it is very, very important for me. And I used to come there every year. But this year I marked by some health problem and underwent surgery. So I cannot come this year. But I'm very happy to be with you online today. Okay. First, I would like to welcome Dr. Karan, and we have to start our session now. The first presentation will be presented by Dr. Shaiti Nai, and the title, Removal of Heavy Metal from Agriculture Wastewater by Forward osmosis process for water reuse. You can start to breathe.
Okay, can I start right now? Can you hear me right? Okay.
Yes, sir.
Okay, I'll share the screen.
Yes,
Okay, right now, do you see the full screen, right? To make sure that this is okay. It's okay, right? Okay,
Yes, okay.
Okay. So first of all, I would like to give my respect to everyone. My name is Satini. I am from Cambodia. And today I would like to share with you about my research work about the removal of heavy metal from the agricultural wastewater by forward osmosis process for water reuses. So here is the outline of my presentation today. And so I will begin with the question like, what is wastewater? Actually, wastewater is water have been used, and according to the UN World Development Bank, 2017, over the 80% of the world wastewater released to the environment without any treatment. So all those source including domestic, industrial, and also agricultural wastewaters. So because recently agricultural wastewater have received more attention because of its complex made up like complete from like antibiotic, pesticide, and also heavy metal. And now you can see in the right hand side picture is the generation source of the heavy metal into the agricultural wastewaters. So due to the difficulty and of the gradation of heavy metal and also the overload of it can lead to impact on the plants, also humans life, also the aquatic life. And you can see there are some diseases that's caused by the heavy metal. So therefore, removal of heavy metal from the agricultural wastewater is really necessary. So in order to make sure that it is okay for the discharge into the water body, you have to follow the permissible levels, and you can see in the table ones. So there are several treatment technology like including chemical purification, ion exchange, absorptions, also membrane filtration. So among the membrane filtration, including microfiltration, ultra filtrations, nano, even reverse osmosis, and also forward osmosis. But among these treatments, like forward osmosis is recommended to use for removal heavy metal because of the several reasons like high rejection performance, low energy consumptions, and also high water recoveries, and also environmental friendliness. So here is the literature review. Like, as you can see in the table 2, it is a typical range of the heavy metal concentration and also the contaminant substance that have in the agricultural wastewaters. And you can see this one is the previous study about the forward osmosis on the mercury rejections. You can see the high rejection will achieve up to 98.2 of using 1 sodium chloride, and also again it was a very high when using magnesium chloride. And if you compare this to magnesium chloride, was so a good performance to use to for rejections of mercuries. So the objective of my work onto removal of heavy metal from the sanitized agricultural wastewater by forward osmosis with the sodium chloride and also magnesium chloride, which as the draw solutions. So here are several scopes. And now let's move on to the methodology. You can see it is study overview. I will begin. Actually, I will start with the experimental setup and also operating conditions, and go to the use the chemical that was used in my work, and also move to the experimental procedure, and the last is the analytical method and data. So let's begin with the part 1 is experimental setup and operating conditions. And you can see in this schematic picture is the system, and they are consist of like kind of the equipment like a conductivity meter, pump, flow rates, membrane, and electrical scale as well. And as I mentioned before, in my work, I was used 2 different type of draw solution like sodium chloride and magnesium chloride with the different concentrations. And for the whole experiment, the pH was adjusted to 7, and the temperatures is about 30 minus or plus 3, and fluid was fixed to 10. And here is the chemical that were used, like copper, chromium, lead, and also zinc. And here is the experimental procedures. And you can, as mentioned, I used 2 different type of draw solution, like sodium and magnesium chloride, and different range of that ones. And for the feed solutions, I used the value that based on the real agricultural wastewater. And pH was adjusted during the experiment as well. And also the experiment was conducted with the active layer first with the feed solutions. And here is the analytical bottom method was used in my work. And you can see the right picture is the analytical instrument that I use ICP for heavy metals. So now let's move on to the result discussions. Let's start with the effects of the resolutions sodium chloride with a different rank on the rejection of heavy metals. And as you can see, the figure is so the rejection of the Cu, copper, like chromium and zinc was higher than 95%, while PB was about only 85 to 92.25 when using sodium chloride. So the rejections was related to the ionic radius, hydrated radius, or also diffusion coefficient, pH, and also folding of this its solutions. And the rejection of the Cu and acetons, as you can see in the graph, is increased when they increase the resolution concentration from 0.5 to 2. And it could be attributed to the occurrence of the external concentrative polarizations, which form the soil reversions from the resolution on the active layers. And also the high hydrated radius of Cu and acetons was more likely to form a strong water molecule and retain hydrated cell. That's why the rejection of these two heavy metals are very high compared to the other. And however, the rejection of the PB was to be less than other due to the high ionic radius of the PB was higher, lighter than the three metal. So as a theory, they said high ionic radius reacted less strong with the water molecules. So now move to the effects of the magnesium chloride, also with the same like different range of its on the heavy metal rejections. And you can see the figure B, it is the rejection of metal by magnesium chloride. And as a result, you can see the Cu received the higher rejection than other because of the pH was adjusted to 7 every hours. So it would be more precipitate and form a like molecular site that cannot pass the membrane. That's why it's the copper very high. And also the rejection of CO and 7 was improved when the resolution increased due to the hydrated radius of magnesium, and also chloride was smaller than chromium and zinc. So it make an increase of reverse salt flakes. And as a result, a reverse salt flake can generate the water through the pores, which reduce the heavy metal absorption and also increase the rejections. However, the rejection of a PB was still lower due to the hydrated radius that easily pass through the membranes when the increasing water flake similarly increase the PB pass through the membrane to the draw solution side. And here is the comparison of these two draw solution concentrations. And you can see the figure D, the water flakes increase when the increasing the draw solution from 0.5 to 2. The result attributed to the increased ICP, which improved the osmotic pressure between membrane and bulk solutions. And also the figure B the same. The reverse salt flakes was lower in the use of a magnesium chloride because of the hydrated radius of magnesium is less diffused than sodium. So additionally, magnesium chloride has a great electrostatic interactions between the membrane and external solution, which enhance the salt selectivity. And also from the figure A to the C, show that heavy metal rejection was lower in using magnesium chloride than sodium chloride because of the multivalence items enhance the dolence effects between the membranes and the solutions. Another reason is that the soil rejections increased under the electroneutrality requirements, which is also rejects the counter items. And also, you can see this is the comparison to the standard, especially to the Thailand, and also for FAO, it's called food and agricultural organizations. We can see from using both the solutions, they show that the treated water could be charged into the irrigations because it's under the standard of the Thai, also from the Food and Irrigation Organization. But however, except only chromium from the using of magnesium chloride, that they cannot pass through the valves because a very high and very large amount in the feed solution. So the suggestion after this one, we can use a post treatment that should be used after using the IFO system for the further treat of the chromiums. Okay, so now is let's move to the conclusion and recommendations. So the heavy metal rejection was obtained very high when we increased the draw solution combinations due to the occurrence of the external concentrative polarizations. And actually all heavy metal achieved more than 95% except PB due to the its hydrated radius and ionic radius. And interestingly, in using magnesium chloride, the rejection of the Cu was approximately more than 97% because of pH of the solution affected Cu precipitation in the feed solutions. And for the chromium and sand rejections was improved by the aerosol flakes that attach the salt and then it can increase the water flakes. But PB still decreased, which because of the low hydrated radius, and it's easy to pass through the membrane. And for comparison between the sodium chloride have give a high rejection compared to magnesium chloride. And additionally, see copper similarly show a good rejection at various concentrations in the in using sodium chloride and magnesium chloride, while PB and CO ends with lower in using magnesium chloride due to the dominance exclusive of the multivalence. And the heavy metal contained in the after treatment was able to use for the irrigation purpose according to the Thai standard and also FAF, but except only the CO they cannot pass through, but we have to do more the treatment to get the chromium can be discharged to the water body. And for the recommendation, actually this one is the sanitized wastewater. So for the real water should be conduct to examine the performance of the heavy metal and impact on draw solution concentrations, and also the pH and the flow rates of the system should be considered during the operation because it can affect utility of heavy metal and also waters on the rejections. So here is the separate reference from my work. Thank you so much. Thank you so much.
Thank you very much, Dr. Shita, and for this nice presentation. And I would like just to ask you one question.
Yes.
About your wastewater sample. Did this sample where spiked it with heavy metals?
Excuse me, could you please again? I could not hear you clearly. Sorry, could you ask the questions again?
I asked you about the samples. Where did you collect this sample? Did you collect it from contaminated area, or you spiked the sample, the water with heavy metals?
Well, yeah, actually, in my work, it's not it was not a real agricultural wastewater, but it's just based on the real wastewater, but it's kind of synthetic wastewater only. It actually not the real ones, but it would be, yes, complex for the real ones.
Yes, okay.
Yeah.
Thank you very much.
Yeah.
Any question, please, for the... Do you have any question?
I have one question.
Yeah.
Why sodium chloride and magnesium chloride are the main candidates for your experiment?
Yeah, thank you for your question. Yes, actually, as the important of my system is the draw solutions, and it plays a main role in my system because we use the sodium chloride and magnesium chloride to extract the water from the feed solutions. Actually, it's IFO system is the opposite with the OO system. That IFO system we operated without using a hydraulic pressure, we use the osmotic pressure. So between this, draw solution plays a role that can be extract the water from the feed solution. That feed solution have a lower concentration, while the draw solution have the very high concentration. So when we use the high concentration as the sodium chloride and magnesium chloride, it means it can be extract the water from the feed solution very well. That's why the magnesium chloride and sodium chloride plays a very best role in the system. Yes.
Okay, thank you.
Yeah.
Yeah, I think. Okay, Prof. Mosat, welcome. Do you want to say something?
Any more questions?
Okay, Prof, because the time is over, so we can move to the another presenter, yeah?
Okay, thank you.
Yeah, okay. Thank you.
Okay, the next one, the next speaker, he is Saif Ahmed from Malaysia. She gonna